Long ago, a man had a mission to attend the College Park High School rave. Would humanity be able to handle Gyrating Gerald's moves? Let's find out. His shoes, fleek. His Rolex, fleek. His shirt, it's okay. Gerald is the complete package. The way he looks at you, his infatuating charisma. But will he be able to dance?
Stop, man.
Oh, come on. Dang it.
Come on, bro. Come on. Ah! What the? Get out of here. Stop it. Stop.
What's wrong?
Your gyrating takes up too much space.
Seeing that he was unwelcome, Gerald was at a loss. Isolated and lonely, he walked away from the rave, devoid of hope. As he walked away, though, a strange, mysterious man appeared in his path. The man beckoned for Gerald to approach. Gerald, out of curiosity, did so. What is wrong, Gerald?
I take up too much space to gyrate at the rave. Everyone hates me. I take up too much space.
I see. I too once had trouble having space to gyrate.
Yeah, I can tell.
I will teach you how to find out how much space you take up when you gyrate, so that you may gyrate freely at the rave.
I don't know. Do I need to know any prerequisite knowledge to learn what you're about to teach me?
AP Calculus AB.
I'm in Pre-AP Algebra 1, dude.
Observe. Gyrate. Stop! 15 centimeters. How tall are you? Approximately 172 centimeters. Now it is time to teach you.
So, I've drawn you here, Gerald. You're 172 centimeters tall as I measured, so that means that the function, if it is a parabola, will be shifted up 86 centimeters on the graphs to make it halfway. Now, I also measured that the depth of your gyration is 15 centimeters. So basically that means this distance is 15 centimeters. Every time you gyrate, this is the furthest point your body gets to. So what we're trying to do is construct a parabola that goes from here, the top of your head, to the farthest point of your body during your gyration, down to your feet. And what we can do is find the volume that this parabola would occupy if rotated around the y-axis, and I'm going to teach you how to do that.
Wow.
Now, since you're 172 centimeters tall, and the parabola opens up to the left, it is a y-squared function. Now we shift it up 86 so that the vertex is midway between your head and your feet. Now we shift it over to the right 15 because the depth of your gyration is 15 centimeters. This will be the function that represents your gyration, Gerald.
Wow.
That's right. Now what we had to do in order to find the integral of that function so that we can find the area is we need to isolate x. Now Gerald, the reason we isolate x is because your axis of rotation is the y-axis. This means that when we're trying to find the area of the function through the integral, we're taking little bitty slices perpendicular to the y-axis. Now each increment is delta y. This means that we need to find the function in terms of y and isolate x.
Wow.
Now when you isolate x, it gets a little bit messy, so what we did here is expanded it and then cleaned it up again. This is the function that you get when you isolate x. Now the volume of a disk has this form of equation. Pi times the integral from y1 to y2 of f of y the whole squared dy. Remember that when we're trying to find the area in terms of y, it's in dy and the function is f of y. Now, we plug in this function into this formula and then we expand. It's a lot of math, so don't check me. I promise I'm correct. Now, this right here is what you get when you square this star function. Now, this is a big fraction. So what are we gonna do, Gerald?
What?
We're gonna separate the integral.
That looks no bueno.
Now, this is what you get when you separate the integral. Doesn't this look so much better?
No.
Now, what we did when we separated the integral is divide each part of the fraction into its independent parts and then distributed the integral from 0 to 172 to each part. Now, the 0 to 172 represents your height from 0 inches to the tip of your head, 172. Then we also took out the pi term since it was a constant to the entire function.
Wow.
After separating the integral here, we have to find the actual integral here. Now, what we do with each part is we use the exponent rule. Now, what the exponent rule means is that we take what is already the exponent and add 1 to it, make that the new exponent, and then multiply the denominator by that new exponent. So y to the 4th over 245025 becomes y to the 5th over 5 times 245025, and so forth with each time. Now the limits of integration get on the right on this bar here, and what that means is that in the end when you're evaluating the integral, you plug in the top end of the limit of integration and then the bottom end, and you find the difference between the two. Now, once you plug in the limits of integration, after finding the antiderivative of the function, you simplify, and in the end, don't forget to multiply by the pi that you took out as a constant before you separated the integral. Then, once you multiply pi by this big ol' fraction, you get the volume that is taken up by when your gyration function is shifted around the y-axis and rotated. This number is 20,680.425 centimeters cubed.
I'm thick.
Now, with this information that I've given you, it is time for you to go and gyrate on your own.
What can I do to repay you?
$400.
What?
I'm kidding. Just go and have fun. That is all the remuneration that I will need.
Go dance! I need 20,000 cubic centimeters to gyrate.
And thus, with the help of the gyrating master, Gyrating Gerald was able to succeed and rave. He was accepted among his peers and heralded by everyone.
Coordinate graph, okay? This is you.
I'm hot.
Whatever you say, Ryan. I mean,
Gyrate.